I'm going to do the 30-second sum in sahodaya paper. So you have a converging beam of light is meeting at a point P. Now in the path of it, a glass sphere of refractive index 1.5 is inserted. Since the incident ray is like this, you should always decide which is the pole based on where the rays are incident from. It's coming from rarer into denser medium, and this is the direction in which the incident ray is coming. So this acts like a pole. Okay, but since this has been given as P, I'll call this pole as P dash. And it's been given that this entire, the refractive index is 1.5, this entire radius is, the diameter is 10, and this distance is 20 centimeter. You know the object is this virtual object which is going to serve as a virtual object will be at a distance of this 20 centimeter. So U is equal to 20, which is right side of the pole, so this is positive. Here the ray is coming from rarer to denser only. So rarer to denser is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. So mu2 is 1.5 by V you don't know, minus mu1 is 1 by U is 20, which is positive, is equal to mu2 minus mu1 by R is just 5. So with this let's find out what is V. So then 1.5 by V is equal to 0.5. So can I just write it as 5 by 50 plus 1 by 20. So 1.5, but radius is negative or positive. Radius is here, it's only positive, it's not negative, so it's plus 20. So it comes there. And so 1.5 by V is equal to, let's write it as 100. 52 is 100, so 5 2s are 10 plus 25 is 100, so 15 by 100 is equal to 1.5 by V. This and this get cancelled, and this and this get cancelled, thus you get V is equal to 10 centimeter. So this is the way to do this sum. Okay, and also draw the ray diagram. So since you know V is 10 centimeter, which means it's getting here. This is where your actual final image is. It's bending. So the most important factor is you have to decide where the ray is coming from and decide on the pole. The pole is here. Even though this is the position of the object, you should measure the whole distance and keep U as 20. So that is something we should be very careful about. Okay. So then next, what is the question? Introduce a path and find the calculate new position. Also find the ray diagram for them. Yeah, it's done. So we have drawn the ray diagram. That's all. Okay, so you know if you have to draw a normal, you can join this center and this point, and it's going to bend towards a normal. The ray that's coming is bending towards a normal. Similarly, you can draw a normal, so you can really understand how it's done. This is a perfect example of how it should be done. Okay, let's go to next question. Can the interference pattern be produced by two independent monochromatic identical sources of light? So this question, I hope it's recording. Is it recording? Yeah. So two independent source of light will not be coherent. So two independent, if it is coming from one single source of light and there are two slits, it will definitely be coherent because there will be continuous, it will emerge out continuously. So then therefore, we can say that it will not be coherent because they cannot emit wave continuously. The two different will not emit wave continuously. It will be two, they will be discrete, correct? It will not be continuous. So then therefore, only from one single source it has to be for us to get coherent. And so can the interference pattern be produced by two independent monochromatic identical source of light? No, not from two independent. Okay, it has, because it has to emit waves continuously. It has to be, for interference pattern to form, the first condition is that it has to be coherent because we need the continuous emission of waves. So that is the reason. So then I hope you understood. Let's go to B. A parallel beam of light of wavelength 500 nanometer falls on a slit, and the resulting diffraction pattern is observed on the screen 1 meter away. It is observed that the first minimum is at a distance of 2.5 millimeter from the center of the screen. The first minimum is a distance of 2.5 millimeter from the center of the screen. Find the width of the slit. This is okay. Let me check if this is diffraction or uh, a parallel beam of light of wavelength 500 nanometer falls on a narrow slit, only single slit, and resulting in diffraction. So this is not a double slit experiment. This is definitely only talking about a diffraction. Is observed to be 1 meter away. This is the position of the first minimum. First minimum. Okay, is 2.5 millimeter from the center of skin. Find the width of the slit. Okay. In diffraction, you know that for minimum it will be d sin theta is equal to 1 lambda. So then therefore sin theta is equal to lambda by d, and tan theta is equal to y by capital D. So y is equal to lambda into capital D by small d will be the position of the first minima, and so then you have lambda, which is 500 into 10 to the power minus 9 into capital D, which is 1 meter, by small d is 2.5 into 10 to the power minus 3 millimeter, right? So find the width. So you can, what? No, that is not 2.5. That is the position, the y itself. So you know lambda y itself is 2.5 millimeter. So then 10 to the power minus 3 is equal to lambda, which is 500 into 10 to the power minus 9 into capital D, which is 1 meter, by small d. So small d therefore is 500 into 10 to the power minus 9 by 2.5 into 10 to the power minus 3. So just calculated and got the answer. So let's go to next sum. Is C. So you remember that in the minima's condition is this is what you achieve. Okay. So in the case of diffraction, two coherent sources of light whose intensity, so the ratio, two coherent sources of light whose intensity on the ratio I1 by I2 is equal to 81:1. Okay, and you know producers of range, calculate the calculate the ratio of intensity of maximum I max by I minimum. You know is A plus B the whole square by A minus B the whole square. You know that intensity is square of amplitude. So for the incident ray, this should be A square and this should be B square. So then therefore A by B should be equal to 9:1. So then you can, if you know A by B is 9:1, you can just write A by B by taking B out. A by B plus 1 the whole square. Taking B out, A by B minus 1 the whole square. B and B get cancelled. 9 plus 1 the whole square by 9 minus 1 the whole square. So it's 10 square by 8 square, which is 100 by 64, which is 50 by 32, or 25 by 16. So I max by I minimum is this. Let me check my answers correct. 33rd question. Use Biot-Savart law to derive an expression, which you can do. I'm only doing the numericals. So I'll do this numerical where there is a circular loop in which the current is coming like this I and leaves like this I, and you know the central angle being 90 degree, and the moment you know that, you know this length will be L by 4, the balance length will be 3L by 4, and you know that they both are in parallel because the current is getting split, and resistance is directly proportional to length and the current is inversely proportional to resistance. So this will be 3I by 4 is the current, this will be I by 4 will be the current across this loop. So let's find the magnetic field due to this, you know, magnetic field due to this curled finger, and the magnetic field will be inward. Due to this it will be inward magnetic field, which is generally mu naught by 2 into I by A, but it's 1/4 of the wire, so 1 by 4, which will make it mu naught by 8. So it will make it mu naught by 8 into I by A, where I itself is 3I by 4, so 3I by 8 4s are 32. So let's find the magnetic field due to this part of the wire. You know, curl your fingers in this direction, it will be outward. So then B outward is equal to mu naught by 2 into I by A for the full coil, but it's 3/4. So write 3 by 4. And I itself is I by 4. So this becomes 16 and will become 3 by 32 into mu naught by 2 into I by mu naught into the same I by A, and therefore outward and inward are just exactly the same. And so the net magnetic field will be at the center is equal to 0. So that I understood. Let's go to next question. This question is B, which they wanted. There's a north pole and there's a south pole, and you have a rectangular coil which is like E, F, G, H, you know that the current is flowing in the clockwise direction. To find the magnetic moment, so normally torque is equal to mb sin theta or m cross b. So if you know the direction of the torque and b, you can find magnetic moment. You know the direction of the magnetic field is like this. Yeah, but we don't know the direction of the torque, so then I will tell you how to find the magnetic moment's direction, which is nothing but area vector, which is always normal to the plane but depends on the direction of the current. So therefore, it may be inward or outward, but here it's clockwise. So curl your finger, you can use the right hand thumb rule again. Curl your four fingers, that curled fingers in the direction of the current. The thumb will go inward, which shows that the area vector is inward. So clockwise means area vector is inward or moment is inward. Anti-clockwise means area vector is outward or moment is outward. Just remember this, or you can use the similarly, current is flowing like this. It's a horizontal plane, we have placed a loop. The curled finger indicates the thumb is upward, and that determines the area vector or the moment vector. But if in the same case is going to be clockwise, the area vector will be downward, and so the magnetic moment will also be downward. Very, very important. I hope you understood how to find the direction of the magnetic moment. Okay, so then when is the torque acting on this loop, maximum, minimum? Okay, torque is nothing but mb sin theta. Okay, when theta is equal to 0, torque will become 0. When will theta be? Theta is basically the angle between the normal and the magnetic field. Normal and the magnetic field. Okay, the normal and the magnetic field, which is nothing but the angle between area vector and the magnetic field. Area vector and the magnetic field. So the torque is 0 when the area vector, okay, let's see, and the magnetic field are parallel to each other. That will happen if the magnetic field is like this. The coil is like this, and the area vector is like this, and the magnetic field is like this. For the area vector to be like this, what should be the direction of the current? Obviously, you can use. Okay, let's not get into that. This area vector is like this, the B is like this, because they've already given everything, right? Okay. So A and B, but the thing is, the area vector, will it be like this? In this case, the current is going to go like this. The area vector will be in this direction, right? It's going to go like that, and area vector will be in this direction. But anyway, it is angle between them is 180. It doesn't matter, but still whether theta or 180, it's going to become 0 only. And if it was in this direction, then we can say that if it was in downward direction, we can say the area vector and B are parallel. But in this case, we can say the area vector and B are anti-parallel. But 180 degree, but at the torque is 0. So this is the orientation, and that is when the torque is 0. The torque is minimum. Torque is minimum when theta is equal to 0. Theta is equal to 0, or I should write theta is equal to 180 in this case. That is this question. I should not write theta is equal to 0. Shouldn't it be theta is equal to 180 in this case? Okay, let me explain. Okay, so we have already studied about the rectangular coil in which if we have current which is going in anti-clockwise direction, this will come up and this will go down. We have learnt it. But this is like the other way, the current is in this direction. Okay, so we can straight away say that this is going to not go up, it's going to go down, and this end is going to come up. So in this position, the end that's come up is this, where the current is in this direction. That solves the problem. So current is in this direction, so you keep a curled finger in this direction, you get the magnetic moment, right hand, you get the magnetic moment or area vector in this direction. The area vector in the magnetic field is making an angle 0 degree, and that's when the torque is minimum. Okay, let's look at torque when it's maximum. Torque is equal to mb sin 90. That's when it's maximum, where 90 is the angle between the normal, that is area vector, and the again normal means area vector and the magnetic field. It's making the normal and the magnetic field, so which means this is how it should be. So then the normal vector and the magnetic field will make an angle 90 degree, and so that's when, so this is the plane magnetic field and this is the coil. So if it is lying in the same plane as the magnetic field, the torque will be maximum. So it will be MP. So you understood these two conditions, okay? So it's not 180 because I am saying that other limb has come here. So it makes sense. I'm being more precise and very detailed. That's all. So that answers these questions. Okay, do you have anything more? So then I'm just dealing with section E. Um, Derive an expression for the capacitance of parallel plate capacitor with dielectric where thickness T is less than D. Oh, that is an old derivation. You can write that. Two identical parallel plate capacitors A and B are connected to. 1 second, hold on.